I'm going to be talking today about some developments that we've been looking at here at Abacus, looking at incorporating body condition scores, some changes in looking at the U-weight penalties and non-linear number of lambs born into the indexes. So this is work that I've been doing with Tim Byrne and Peter Amer at Abacus. So just some background on this. We have been, like I said, continuing to refine the index, and we're looking at the New Zealand Maternal Worth Index here. And recent developments that we've got an evaluation now for body condition score, and we've calculated an economic value, so we're looking at incorporating that. Looking at reviewing the penalty that's currently put on U-weight and its impact on rankings, and later on Tim's going to be doing some more discussion on that topic. And also incorporation of a nonlinear economic value for a number of lambs born, especially in relation to how that affects really highly prolific genetics. So what we did for this presentation is we tested some variations on that NZMW index for the effects on RAM rankings and predicted selection response. So this is the index then that we're looking at. So we're looking at the total index that consists of growth, adult weight, meat traits, wool traits, reproduction, and survival. So you can see all these traits here, and each of these traits is weighted by that economic value in cents per unit. So we're looking here at I'm going to be talking today about adding body condition score as an additional trait, changing that U, mature weight, economic weight by 10%, and changing that number of lambs born value then to a nonlinear function. So we did this by testing two data sets. We had a group of young rams, which was a very large group, and these were only 12 months old at time of evaluation, not a lot of information going into those. And then a proven rams group that we consider proven that had, they're older, they had a number of lambs born accuracy over 60%, so there was some information going into those animals. That's a smaller group at 974 observations. So first of all, then, looking at adding body condition score to the index, we got changes in RAM ranking, or this sort of looks at the changes in RAM rankings. First of all, that 1697 there is our new economic weighting for body condition score, so it's just adding that term into the equation. And you can see here there's a strong, or what I've graphed here is the index value, at the bottom the index value, with the current New Zealand maternal worth, and then on the y-axis there, what happens when we add the body condition score into the term. You can see a very strong correlation there, but there is a lot of re-ranking going on. So there's a substantial number of animals that are moving up or down as a result of adding in that body condition score. It's a bit crowded there for the young rams group, but if it's that proven rams group that's smaller, then you can sort of see the individual data points a little bit more. You can see how that correlation is a little bit weaker there too. Next, reducing the U-weight penalty by 10%. So we're looking at changing the economic value down to 134 cents. Again, Tim's going to be discussing that a little bit more. But here we have a much stronger correlation happening between the rams in the current index as it is now versus what it would be if we change that penalty. So there's very strong correlation here and quite a apparent line, not a lot of re-ranking happening. So what we will see in a few slides though is there is some impact in terms of trait responses, expected trait responses, so I'll get to that. And our third variation, looking at the number of lambs born trait. As you're aware, often increasing number of lambs is good, but in practice there is going to be an optimum number of lambs born above which there really isn't any economic benefit of having additional lambs. or even maybe some additional costs. So our current linear economic value is giving the same weighting for NLB to all of the animals regardless of their current prolificacy stating. And the concern about that is that perhaps we have some over-prolific genetics that are in fact overvalued on the full index. And there may be some animals that have very high index, total index rankings that are due mainly to their extreme number of lambs born EBV, and perhaps they're only average for the other traits of importance. So what our nonlinear index then, this is how it compares to what's currently going on. So, so what I've got on this graph here is on the x-axis, that's the number of lambs born EBV, and on the y-axis is their value that is calculated at. So the blue line there, the straight line, is what's happening with our current linear index when we just multiply it by the index weighting for that trait. We've developed this economic function, or this nonlinear function, shown in the black curve there. So what that's doing is there's increasing value for animals up to that optimum point. Here we set this optimum. It's about 1.85 lambs. And above that optimum point, all the animals get the same economic value, so it's plateauing out. What's happening then, so you can see, these are the same animals, by the way, that wasn't clear, but is those really high NLB animals are being dropped down to perhaps what is more a more practical value. If they're overvalued now at that extreme level, maybe this brings them down to a practical level. So we're still at the index, this nonlinear index, is still encouraging improvements in the lower prolificacy flocks, but it's keeping more prolific genetics from badly overshooting things and being overvalued. So what this means in terms of ranking changes, if we look at the populations in general, this is just the proven rams group. We're still getting a strong correlation for the entire group, and this is the current linear one is on the x, but the nonlinear value is on the y. But we're getting some dropping down for a number of animals, and you can see the real changes starting to happen up at the top, up in that top quadrant. So I want to blow that up a bit. So this is the top 100 proven rams that are in that box. And you can see there that we're getting a lot more sort of variation happening due to that nonlinearity. So, sorry, a lot more change happening due to that nonlinearity. You can see there's even a couple of very visible rams there that have dropped, that their value originally with the current linear index was very high. But now, and probably largely driven by that NLB, EBV, and those ones are being dropped down in value now with our nonlinear things, or with our nonlinear function. So, so this is especially affecting those elite or high NLB animals, high NLB genetics. All right, so I've presented a few of these correlations. Basically, so we can look at sort of what happens with these individual changes in the young rams, proven rams, and those top 100 ones, some correlations. We also looked at, on the bottom row there, combining all of these changes together, what happens. So you can see rank correlations of rams are quite strong quite strong. We're dropping a little bit less reduced correlation with the proven rams because they have more accurate EBVs and there's more spread in their values. So that will change that means a slightly weaker correlation. And also similarly for the top ones. But the real change, especially for the nonlinear, is happening with those top 100 animals. Next, we want to look at the predicted selection responses. So I'm taking a subset of traits. So here I'm just going to look at a few growth and meat traits. And what happens, we have predicted responses with the current index there on the left, and then comparisons when we add, or responses when we add in that body condition score, that change in U-weight penalty, and then the nonlinear, and then adding all of these three changes together. And you can see, so what we want to do is compare those numbers against what's happening at the current level. So we'll see some generalizations is that adding body condition score to the index is going to be increasing our growth responses, getting a bit more weaning weight, carcass weight. We're also improving lean yield. Same with changing the U weight penalty. That's also going to be driving things more towards growth traits. And driving things more towards growth traits. The changes in reproduction traits. So here, I'm just going to look at the number of lambs born. So comparing that again against what happens at the current, with the current index, adding in our nonlinear, so the two numbers at the end, we're seeing that we're going to be reducing our change in number of lambs born a little bit, so we are restricting that. However, like we said before, or like I described before, we're still looking at the population. These numbers are from a linear production, and it's not really giving the full picture of what's happening with those extreme animals at the end because of that nonlinear aspect. So we also looked at what happens when you, what happens to the mean NLB when you rank animals according to the linear or nonlinear index. So we took the top 30 rams according to the linear indexes and found that they have a mean number of lambs born EBV of 0.35, whereas if you take the top 30 rams according to non-linear indexes, they have a mean NLB EBV of 0.29. So you're seeing a noticeable drop there in terms of what their mean NLB was for those very elite animals according to the full index. So basically what this is showing is that by adding in that non-linear component, I should be saying here, we're not only selecting animals for extremely high NLB anymore. So there's some compensation being made. So just a summary then, we can say that adding the body condition score to the index is going to favor meat yield, growth rate, bigger U's generally. If we're going to reduce that U weight penalty down, it's going to increase the emphasis on growth rate, but we still do have that aspect in there of controlling the U size. And adding in a nonlinear NLB aspect is a critical index development. We still have the point that animals with low NLB EBVs will still get a low sort of overall reproduction value, but animals with high total index values are more likely to be sort of more balanced across all the traits and not driven only by extremely high NLB EBVs. Finally, we've just proposed, we have some proposed recommendations. First of all, that all three of these changes be incorporated into sort of new trial standard indexes. So these could be available alongside of the current standard indexes and then be available for a year of feedback before a changeover. And as I've shown here, all these changes can be available either as options individually or all combined together as we show. So, so that's our index developments. Great, thanks.